This is Pre-Calc 11, Chapter 8.3. We're going to be looking at graphing reciprocals of linear functions. So what that means is we're looking at g of x equals 1 over f of x, where f of x is equal to ax plus b. And let's start off with something basic. Let's just have f of x be x. So g of x is just 1 over x. And it's best to reason out how we're going to graph this. As x gets large, 1 over x is going to get smaller. So 1 over something big is going to give you something small. Similarly, as we look at x approaching 0, anything getting really, really small or close to 0, 1 over x is going to get larger. So if we do 1 over 0.01, we get 100. If we're looking at 1 over 0.001, then we get 1,000. And if we look at what happens when x is less than 0, everything's the same, but the values are negative. So 1 over negative 1,000 is going to be small, but negative. And if we look at negative 1 million, again, it's going to be small, but it's going to be negative. If we look at negative 0.01, we're going to get negative 100 as 1 over that. And 1 over negative 0.001 is going to be negative 1,000. So it's going to get bigger in that direction. When we have this, we have a vertical asymptote at x equals 0. So a vertical asymptote just is vertical, but as the values get closer to it, it goes to either positive infinity or negative infinity. So that's the definition of asymptote. Values getting close, but not actually reaching it. We can't actually do 1 over 0 because 1 over 0 is undefined. Okay, we have a horizontal asymptote as well in this case. So as x gets large, positive, it approaches 0. It doesn't actually touch 0. And this is y equals 0. Before it was x equals 0. And again, if we get negative large, it approaches 0, but it doesn't actually get to 0. So again, that's an asymptote. This one's called a horizontal asymptote. And here, the domain is x does not equal 0, and the range is y does not equal 0. So we're going to do this analytically. Graph 1 over negative 3x plus 7. We need to find out where the function is undefined. So we have negative 3x plus 7 equals 0. So we're looking for zeros again. Negative 3x equals negative 7, x equals 7 over 3. So x equals 7 over 3 is the vertical asymptote. Okay, that's a lot to write, so we can abbreviate this as VA. And we also want to say no changes as x approaches plus or minus infinity. So our horizontal asymptote, y equals 0. Okay, so if we put something really big here, it's going to be still y approaches 0. And this is always the case for reciprocals of linear functions. So you can just put this down as a rule if you like. There's also another difference. And we're talking about a difference from this function. Minus 3x plus 7 is greater than 0. So negative 3x is greater than negative 7, so x is less than 7 over 3. So this means we're getting positive values when we're moving in this direction. Okay, let's plot our vertical asymptote. So we're plotting above the x-axis. And to the right of the vertical asymptote, we're plotting below the x-axis. So x is positive, left of vertical asymptote, and x is negative, right of vertical asymptote. And our domain, x does not equal 7 over 3, and our range, y does not equal 0. Let's look at something that will help us graph. Invariant points. So basically, we normally look at f of a equals a, but since we're graphing reciprocal functions, we're actually looking at g of a equals 1 over f of a, and we want that to equal f of a. So this happens when f of a equals plus or minus 1. Since 1 equals 1 over 1, f of a is 1, g of a equals 1 over 1. And negative 1 equals 1 over negative 1. Okay, so we're looking for this case here. And you won't find any other invariant points. We can't plug in 0. And again, if we go something big, this is going to be small. If we go something small here, this is going to be big. So the only points that we're going to solve for this is 1 and negative 1. However, there's a simpler explanation. We just want to find out where they intersect. And the NPV is also where the vertical asymptote is. And that's NPV. We talked about domains. NPV is simply your non-permissible values. Okay, and again, we're solving for zeros. We just, for any f of x equals ax plus b, we just solve. Move the b over to the other side, divide both sides by a, we get x equals minus b over a. Okay, so here's another example. We want to graph y is equal to 1 over negative 2x minus 3. Our non-permissible value, negative 2x minus 3 equals 0. Negative 2x equals 3. X equals negative 3 over 2. And again, you could have just used this formula. We would have had minus negative 3 over negative 2. And that becomes 1, 2, 3 negative signs. It's minus. Okay, we want to check out where x is positive. Negative 2x minus 3 is greater than 0. Negative 2x is greater than 3. X is less than negative 3 over 2 because we're dividing by negative 2. This is the positive line. So we have this. X is less than 3 over 2. Draw a vertical asymptote. Vertical asymptote, x equals negative 3 over 2. Our invariant point is 1. And we're going to the vertical asymptote. We're going to the horizontal asymptote. All from the positive y side. And where it's not positive, it's negative. So again, we still need our invariant point, -1. And we're going to the vertical asymptote on the negative side, and we're going to the x-axis on the negative side. So here's your procedure. We plot f of x and the asymptote. We draw the invariant points, and then we draw the curves to infinities. And that completes this lesson.